Okay. Okay, for the example number 3, okay, a clay layer as shown in figure Q23 is to be compressed by surcharging in order to reduce the total settlement of a proposed structure. Okay, the surcharge will be completely removed after the required degree of consolidation is achieved. Okay, based on a double drainage consolidation test, okay, the compressions and rebound indices are CC 0.4 and CR 0.08 respectively. Okay, so A, B, C, and D. Okay, we go first for the A. Okay, determine the effective vertical stress at the midplane of clay layer. Okay, so I guess all of you know, okay, how to determine the effective stress, okay, on the clay at the midplane of the clay layer. Okay, 3 times 17, 2 times 18.5 minus 10, and then half of 16 will be 8. 8 times 18.3 minus 10. Okay, so that is the effective vertical stress at the midplane of the clay layer. So the result is 134.4. Okay. B, the consolidation settlement, if the proposed structure will exert an average stress increase, okay, which is 30 kilonewton per meter square at the midplane of the clay layer, assuming the clay swell after the removal of the surcharge. Okay, use over consolidation ratio OCR 1.3. Okay. Okay, let me uh, sketch, okay, what is the step, okay, during this construction stage, okay. Okay, saya kena sketch dulu kejap supaya awak faham. Okay, saya buka pen. Okay, kejap Okay. Okay. So, awak nampak saya punya pen ni, nampak tak? Hello?
Nampak doktor?
Okay,
Nampak.
nampak Okay. Okay. So, okay, buku depan awak, okay. So awak tengok dia punya step yang berlaku. Okay. So you just imagine, okay. Mana ni? Okay. This is the ground. Okay. Then first sentence mention that they will apply a surcharge. Mana surcharge ni contoh dia macam ni. Okay. Dia akan letakkan satu beban. Okay. Okay. Tapi sekejap sebelum tu. Okay. So okay, this is the ground level. Okay. So then they will apply a surcharge on the top of the ground. Okay. Okay. The surcharge will be completely removed after the required degree of consolidation is achieved. Okay. So then after it reach a certain consolidation degree, okay, so then they will remove the surcharge. Okay. So based on B question, okay, if the proposed structure, okay, so uh, the last stage, okay, after the surcharge has been removed, okay, so they will apply, for example, they will develop a building, for example, okay, or any other structure, okay, where the what we call as the average stress increase, okay, at the midplane of the clay is around 30 kPa. Okay. Okay, lebih kurang gitu. Okay. Sebab apa saya kena buat macam ni? Sebab saya nak relatekan dengan OCR or NC. Okay. Okay. As a simple understanding. Okay. So let's say if this is a ground, okay, and then we apply on something on the top of the ground, okay. So we may use the approach of normally consolidated, okay. So because before any structure has been developed on the top of the ground, okay, so there is no the stress history and also the effective vertical stress, okay, under the same conditions. Okay. Okay. So once there is they construct something, okay, and then they remove the structure. For example, for this case, they remove the surcharge. Okay. So the previous stress is higher than the current effective vertical stress. Okay. So in that case, we may consider as a over consolidated if we want to develop something on the building, on the ground. Okay. So that's why for the question B, okay, Dr. Kamaruddin has mentioned that the OCR is equal to 1.3. Okay. So it means that the soil, okay, currently experience an over consolidated ratio or over consolidated conditions. Okay. So the OCR is equal to 1.3. Okay. Okay. So on the other word, we can determine, okay, the PC or the sigma C, okay, once we know what is the effective vertical stress, okay. So this value should be multiplied with 1.3. So then that is the PC, okay, which is the pre-consolidation pressure, okay. So what is the settlement or what is the consolidation settlement, okay, due to this proposed structure, okay, with the increment of stress at the midplane is equal to 30 kPa. Okay, so kita kena kira lah. Okay, before we start to calculate, okay, so we already know that the OCR have two formula, okay, which is if PC, okay, is equal or greater than delta sigma plus sigma naught, or PC is less than delta sigma plus sigma naught. Okay. So we need to choose, okay, which formula or equations, okay, which is suitable to be used, okay, to solve the question B. Okay. Clear? Ada soalan? Yang ini kalau awak tak dapat tangkap ini, awak akan ada problems. Okay. Untuk imagine the problems. Okay. Unless if they provide the PC, okay. Let's say, okay, the questions, okay, where you need to draw the E log P, okay. So from there you can get the what we call as the PC value, okay. Okay. So from there you can get the PC value. So you can use the PC, divide with the what we call as divide with the effective vertical stress, then you can get the OCR value as well. Okay. Ada soalan? Okay, saya anggap faham. Tunjuklah sign bagus ke apa ataupun cakap okey ke. Najwa. Okey. Terima kasih je Najwa. Okey. Okey, terima kasih. Kalau tak nanti saya ada Kim, senang ada masalah, beritahu je lah. Okay? Okey. So saya stop. Okey. Awak salin tak yang saya lukis tadi tu? Okey. Nanti awak tengoklah video. Okay? Okay, so now to solve the question B, okay. So we look how the solution for the question B, okay. So in this example, okay, we are encountering an over consolidated clay, okay. As such, two cases need to be considered, okay, where PC greater than, okay, what I have told you before, okay, PC greater than sigma naught plus delta sigma, or PC is greater less than delta naught plus delta sigma. Okay, so let's check the value of effective stress plus delta sigma, then compare to the PC, the value of the PC. Okay, before we check, yeah, we can check directly the value. For example, 134.4, which is the vertical stress, plus the 30 value that's been provided in the question. Okay, so the value is 164.3. Okay, so that is for the delta sigma plus sigma naught. Okay, so since OCR is equal to 1.3, okay, then we use the formula of the OCR equal PC over sigma naught. Okay, so then 1.3 multiply with 134.4, so that is the value of 174.72, okay, for the PC. Okay, so now we may compare the value of the PC with the value of the sigma naught plus sigma delta sigma. Okay, so the value is greater than the sigma naught plus delta sigma. Okay, so in that case, we may use the first formula, okay, which is require the rebound index CR only to calculate the consolidation settlement. Okay, so the sketch below should explain why CC is not required. Okay, so the idea is when we look on this sketch, we may know that the CC is not required, okay, because the value is less than the PC. Okay, so that's why we use only CR. Okay, as a reminder, reader are strongly encouraged to sketch this diagram whenever calculation of consolidation settlement of over consolidated is required in order to identify which equation to be used. Okay, so you can just sketch for this kind of what we call as a graph, okay, whereby from there you can identify which parameter that you may consider, okay, during your calculations. Okay, so for this case, PC is greater than sigma naught plus delta sigma, so no need to consider for the CC, only CR. Okay, so the equation is H naught over 1 plus E naught CR log times delta sigma plus sigma naught over sigma naught. Okay? So before the settlement can be calculated, the initial void ratio should be determined using equation in soil mechanics. Okay, so just the same formula that we have already used previously. Okay, so to get the E naught, G times W. Okay, GS times W. So we get the E naught is equal to 0.91. Okay, then put the E naught inside the equation. Okay, then we can get the delta H is equal 29 millimeter. Okay, so supposed to be no question because it's already been presented in the reference book. Okay, so now we look on the question C. Okay, The consolidation settlement 12 month after placement of surcharge. Okay, if the coefficient of consolidation is equal to 3.75 meter square per year. Okay? So he determine the average degree of consolidations. Okay? So the question is, what will be the settlement after 12 months? Okay? After placement of surcharge. Okay. So to solve this problem, okay, we may use this formula, which is CV equal to TV times HD square over P. Okay, so the CV has been provided here, 3.75 meter square per year. Okay, while the TV, okay, yeah, in this case, we want to determine the capital TV, okay, the capital TV, okay. So the T time is given here, which is 12 month, okay. The HD, because it is a double drainage condition, where the sandy gravel under the clay layer and the silty sand overlaying the clay layer. Okay, so it is a double drainage system. So 16 over 2 is equal to 8. Okay. Okay, once then we get the TV value. Okay. So the TV value is equal to 0.06. Okay. So that is the time factor. Okay. So for the time factor, we need to determine what will be the degree of consolidations. Okay. So there is a relation between TV and UV. Okay. So you can look on the figure 2.2. Okay. So the result of the UV is equal to 28%. Okay. So note that consolidation settlement at any time over total consolidation settlement. That is the UV. So it's not a linear equation. Okay, so you need to refer to the figure. Okay, or you can use the formula which is from 0 to 60. Okay, there is one formula, and from 60 to 100 there is another formula. If you want to get the most accurate value compared to when you refer to the graph. Okay. So UV is equal to 28. Okay, means that the degree of consolidation is 28%. Okay. 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 So those 12 months after placement of surcharge is equal to 0.28 times 29. Okay. So 29 is from the B. Okay. Then multiply with 0.28. So the value is about 8 millimeter. Okay. Okay. Any question? Yes, no? Okay, boleh. Clear. Boleh tak? Senyap lah.
Boleh, Doktor.
Okay, terima kasih. Okay. So then we move to D. Okay. Saya tengok soalan D. Sambil-sambil tahu awak tulis-tulis lah apa yang saya cakap. Kan? Buku tu buku awak, jangan biar kosong. Okay. So the consolidation settlement, if the proposed structure will exert an average stress increase, okay, delta sigma of 60 at the midplane of the clay layer, assuming the clay swell after the removal of the surcharge. Okay. Okay, use over consolidation ratio OCR equal to 1.3. Okay. So B the value is 30 and D, the value has been increased double to 60. Okay, so definitely the D, we may use the second equation of the OCR. Okay, if we still use the same equation, so I guess Dr. Kamarudin uh, will not guide us on how to use the second equation if it is remain using the same first equation. So that's why he increased from 30 to 60. Okay. So repeat this almost the same procedure with B. Okay. So we need to compare. Okay. The new delta sigma plus sigma naught. Okay. Which is 194.4. Okay. So the OCR is 1.3. Okay. So the value of the PC is less than the sigma naught plus delta sigma. Okay. So both the compression and rebound indice CR and CC. Sorry, CC and CR. So dalam buku awak betul tak CC and CR? Oh, saya saja silap. Cuba cek. Sepatutnya adalah CC, not CR dia. Ni pun sama tak? Kalau saya punya buku lah, buku lama. Betul tak? Macam mana awak punya CC atau CR dia bagi? Hello.
CR and CR.
CR. So awak betul kan eh? So tulis sini CC and CR. Okay. So yang ni CC, not CR. Okay. Okay. So this is refer to rebound, while this is refer to compression. Okay. Actually, jangan saya tunjuk contoh. Okay. Okay. Sebenarnya the CR, okay, bukan berlaku di situ sebenarnya. Okay, dia macam ni. Contoh turun sikit. Lepas tu dia turun lagi. Okay. Lepas tu, yang ini baru recompression. Okay, this is will be actually this the whole is compression. Okay, keseluruhan ni compression. Okay, so they use the most steepest slope. Okay, to represent the CC. Okay, while this is the CR actually. Okay, walau bagaimanapun. Okay, the pattern or the slope degree. Okay, almost similar. Okay, with with the yeah, we call it as the first curve under the compression curve. Okay, so that's why this is still used as the CR. Okay, by right, this is not the CR result. Okay, but due to the degree of the slope, okay, almost same. Okay, so that's why they use or mention, okay, the first degree, the first curve as a CR. Okay, jangan awak confuse pula eh. Stop. Okay. So as I told you previously, okay, Dr. Kamaruddin has introduced the delta sigma 1 and the delta sigma 2. Okay. So if you want to use this delta sigma 1 and delta sigma 2, okay, so you need to plot based on Dr. Kamaruddin equations. Okay. So on the other hand, okay, as I mentioned previously, okay, based on the slide, okay, so there is a difference in terms of the equations or the notation of the equations. Okay, So the appropriate equation to be used is equation 2.3. Okay. So yang ni kekal macam biasa. Okay. So they have a CR log sigma naught plus delta sigma. Okay. So sigma naught, which is sigma naught here plus delta sigma. Okay. So actually the value is equal to PC kan. Maknanya daripada sini ke sini bersamaan dengan PC. So we can use the PC, okay, to represent the delta sigma 1. Okay. So then we have a CC log PC plus delta sigma 2 over PC. Okay. Or on the other hand, we can use sigma naught plus delta sigma. Kan? Kita guna terus sigma naught plus delta sigma. Okay. Sebab apa yang ini dah mewakili nilai sigma naught plus delta sigma jika if we are referring to the to my slide. Okay. So okay, whatever equation you use, as long you know and you feel that it is easy to understand, so it is up to you. Okay. So for me, I prefer to use the one that I have discussed based on the slide. Okay. So based on the shown sketch, the stress increase delta sigma has to be divided into two parts. Okay. So yang ni ulang balik ni. Okay, berapa? Okay. So Dr. Kamarudin still use the concept of delta sigma 1, delta sigma 2. Okay. Okay. So let's say if you use the PC, okay, if you use PC, 134 campur 40.32 sama juga kan? That's the PC. Okay, this is the PC. So no need to differentiate between sigma naught plus delta sigma 1. Okay. Okay. So 0.04, 0.4. Okay. So actually in the C, okay, or in the diagram, in this diagram, okay, delta, or in the question, okay. So there is a difference between the value of the CC, sorry, the value of CR, which is 0.08 and the value in the diagram. Okay. Awak punya buku betul? Buku awak? Sama tak ni? CR dia sama juga dengan delta sigma, value of in the diagram. Sama atau tidak? Kalau 0.08 juga, you need to change to 0.04. Cuba cek. Awak perasan tak ni?
Sama doktor.
Dapat?
0.04.
Tak dengar. Kuat sikit.
0.04.
Oh, dekat sini 0.04 eh?
Uh-uh.
Okey, ni buku lama. Okey. Okey, so betul lah tak ada isu. Okey. Okey. So dah betul tak ada isu. Okay. So we just put the input, okay, on the equation. So we gain 19.4 centimeter. Okay. So that is for the question number 3. Okay, ada soalan? Ada soalan? Tak ada Okay, good. Okay. So now we move to question number 4. Okay. So the soil profile of a project site is shown in figure Q24. Okay. So this is the figure. Okay. A proposed constructions project will involve compressing the clay layer by placing a 5-meter high earth fill. Okay. The clay layer is overlain and underlain by sand and sandy gravel, respectively. The average unit weight of the fill material is 18. Assuming the fill area is large and unit weight is of water is equal to 10, okay, determine, okay, A, B, C, D, okay, A, B, C, D, okay, A, B, C, D only, okay. First, determine the pre-consolidation pressure, okay. The anticipated consolidation settlement due to the placement of the surcharge, the coefficient of consolidation, CV, if a double drainage consolidation test performed on a saturated clay layer with the tabulated and thickness uh, with 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 a diameter and thickness, okay, of the 50 millimeter and 20 millimeter respectively. Okay, refer to the tabulated value obtained from the constant test. Use Taylor square root time methods, okay, to determine the CV. Okay. The time required to achieve 50% consolidation settlement of the clay layer. Okay. So now we move, yeah, we go to the A first. Okay. But we look on the question, okay, with what type of uh, stress history, okay, of the soil experience. Okay. So the soil, okay, a proposed construction project will involve compressing the clay by placing a 5-meter high earth field. Okay. So and that in that area they only put the 5-meter high earth field. Okay. So it means that it is a normally consolidated. Okay. Because before they install or before they put the high the earth field, so there is no any other structure on the top of the soil. Okay. So how to determine the PC? Okay. So the PC should be equal than the effective vertical stress. Okay. So since it is given that OCR is equal to 1, it means that it means the clay is normally consolidated or PC is equal to sigma naught. Okay. Those, okay, we just determine the effective vertical stress, okay, which is 17 times 4 times 18.5 minus 10 times 3, okay, and then 16.16 over 2 times 19 minus 10, okay. So the value is 165.5, okay, for the PC as well. Okay. So B, the anticipated constant settlement due to the placement of the surcharge. Okay, so now we need to determine what is the settlement. Okay, so it is under a normally consolidated. Okay, so we need to get the value of the delta sigma. Okay, so the fill material is 18. So times with the height of the material by assuming it is a large area. Okay, so 15 times 5 is equal to 60. Okay. So the surcharge, okay, we have a same, what we call as the same value of stress, okay, because the area is too large. Okay. Okay, 18 times 5, not 60. 18 times 5 is equal to 90. Okay. So for normally consolidated clay, the equation to be applied to calculate the consolidated settlement is equation 2.1, okay, based on the above equation, the only unknown parameter to determine delta H is delta sigma. Since the field area is large, it is assumed that the stress increase delta sigma is uniform throughout the depth, which equal to the pressure exerted by the embankment. The pressure Q due to the embankment can be computed as, okay, so Q equal to gamma field times H field, okay, so equal to 19, okay. So then we just put the 19, okay, to replace the delta sigma. From there we can get what is the um, delta H value, which is equal to 85. Okay. So now for the question C. Okay. So for the question C, uh, the coefficient of consolidation, which is CV. Okay. So to calculate the value of CV, okay, we have been provided with this what we call as this result. Okay. So they asked to use the Taylor square root time methods. Okay. So for the Taylor square root time method, so we need to square root all the times. Okay. And then we may use the value of the gauge reading to be plotted in the graph. Okay. Okay, so then you can go through the procedure or the step by step. Okay, so then we can have this kind of graphs. Okay, so the first tangent to the consolidation curve we represent as a B. Okay, the second is the D. The second is to um, extend what we call as extend the AB line. Okay. Then from there we can get the C. Okay, the extension should be 0.15. Okay, from any other line, horizontal line. Okay, from the zero x-axis to the line of the AB. Okay, so then we get the AC. Okay, so the intersection between the AC with the consolidation curve, okay, is the square root time. So then we need to power by 2 to get the T90 value. Okay. So the T90 value is equal to 4. Okay. 4 times or 4 power by 2 is equal to 16. Okay. So from there, okay, we can get what is the CV value, okay, which is 5.3 millimeter square per minute. Okay. However, you need to make sure that you use the same, what we call the same units. For example, the HD, okay, 10 over 16 uh, time. Okay. So the HD here is in millimeter. Okay, the HD is in millimeter. Okay, because 20 divided with 2, so it is millimeter. Okay, so your final product before you rearrange the what we call the units. Okay, it will be millimeter square per minutes. Okay, so at the end, if change to meter square per year, so it will become 2.8. Okay, so that is for the C. Okay, and for the D, okay, we have D here. The time required to achieve 50% consolidation settlement of the clay. Okay, so again, we may use the equation of the CV. Okay, CV is equal to TV over HD over CV. So we already have the CV. So now we can count for the T. Okay, normally for 50% of consolidation, the TV is equal to 0.198 or 0.197. Okay, so from there we can get the value of the T. Okay, so again, okay, look on the units. Okay, so then we get 4.5 years. Okay, so that is for the D. Okay, so now we move to the question number 5. Okay, so is there any question? Any question? No. Yes. For the question number 4. Okay, good. Okay, so now we move to the question number 5. Okay. Okay, for the question number 5, the following data were obtained from a double drainage one-dimensional consolidation test on a saturated silty clay. Okay, the sample diameter is 50, the sample thickness is 20, P90 is equal to 18 minutes based on Taylor square root time method. Determine the degree of consolidation achieved in 8.5 minutes during the consolidation test. Okay, I guess it's very straightforward. Okay, you use the CV equal to TV over HD square over T. Okay, so since the time of consolidation was determined based on the Taylor method, the time factor 0.848, okay, is equal to 90%. Okay, so the CV is equal to 4.71. Okay, because we want to determine what is the CV value first. Okay, so um, the consolidation will be completed. Okay, after it reach a 90% of consolidation. Okay, so it doesn't require for us to get until 100%. Okay, 90% is far enough. Okay, okay. So then we get the CV value 4.71. Okay, so rearranging equation 2.6, okay, to get the value of the TV. Okay, so and inserting the appropriate value, which is the CV 4.71 times 8.5. Okay, 8.5 actually, where is 8.5 is the time. Okay, okay, this is 8.5 minutes. Okay, so doesn't require for us to change the CV to year. Okay, because the question is we need to get the degree of consolidation achieved in 8.5 minutes. So we solve first the problems, and then right after that, if you want to change into year per year, okay, so then we can change later on. Okay, so then the T is 8.5. Okay, CV is 4.71 over HD power by 2. So then we get 0.4 for the TV. Okay, so that is for the TV. Okay, so the 0.4 of the TV, okay, to get the degree of consolidation, okay, so we may refer to figure 2.2. Okay, so based on the TV of 0.4, the UV is equal to 70%. Okay, so that is for the question number 5. So we have 6. 7, okay, and there will be 8 and 9, okay. Saya lupa siapa yang share dengan saya itu, yang 8 dan 9? Ingat tak? Hello?
Saya Doktor.
Kori, tak apa. Okay, Kori. Thank you, Kori, eh.
Welcome.
Okay. Ada soalan tak? Nombor 5 tadi. Tak ada, eh? Corin. Kan? Corin Ho, kan?
Ya Doktor.
Okay. Ada soalan nombor 5 ada soalan? Tak ada, eh?
Tak ada.
Okay, thank you. Okay. Sekejap, eh. Okay. So now we move to question number 6. Okay. I guess question number 6 is a little bit difficult. Okay. So it require for us to have a good understanding. Okay. On the OCR concept. Okay. Over consolidated ratio. Okay. So okay. So the soil profile of a proposed project site is shown in figure, okay, Q2-6. Okay. A 100-meter times 200-meter embankment of 5-meter height is to be placed on the ground surface to compress the clay layer. Okay. So the embankment material is soil with a unit weight 18 kilonewton per meter cube. Okay. So then the embankment will be completely removed once the required degree of consolidation is achieved to facilitate constructions of a 50 times 100 meter square. Okay. So awak dah nampak kan? Mula tanah lapang, dia letak embankment, okay. Lepas tu dia buang, lepas tu dia akan construct a new structure. Okay. So sebelum dia construct a new structure, okay. So the soil behave under over consolidated conditions. Okay. So if for any reason the allowable settlement of the proposed structure is 50 millimeter, determine the maximum allowable pressure to be exerted by the proposed structure. Okay. So berapa nilai pressure daripada 50 times 100 structure tersebut. Okay. Yang mana dia hanya allow 50 millimeter of settlement. Okay. Okay. So kita ada satu area yang mana ada building. Okay. Betul, 50 millimeter tu adalah allowable settlement. Okay. So we need to calculate how much pressure, okay, from the building, okay, in order to ensure it doesn't uh, reach above the uh, the the settlement, the allowable settlement, okay, which is the 50 millimeter. Okay. Okay. Dia punya uh, difficulty dia adalah kita ada dua equation untuk OC. Okay. So we need to choose the first one, okay, and then do the calculation. Okay. So if the first one doesn't the first one is not success, so we need to choose, or we need to do the second calculation by using the second equations. Okay. So let we look on the procedure. Okay. So this is the soil layer, silty sand, clay and sandy, gravel. Okay. So refer to the diagram shown below to estimate the increase in stress. Okay. So the equation derived from the diagram is expressed as QBL. Okay. So this is the standard equation. Okay. The size okay, the size of the embankment is 100 times 200. Okay. Okay, so that is the size of the embankment. Okay. 100 times 200. Okay, so we gain 74.78. Okay. Okay. Since the embankment will be removed to facilitate construction of the proposed structure, we are dealing with over consolidated clay, okay, which is PC is greater than sigma naught. Therefore, it's necessary to determine the value of the past maximum effective vertical stress PC that will be experienced by the underlying soil, particularly the clay layer, due to the placement of the embankment. Okay, so uh, before we can get the PC or we can assume the PC value, so we need to get what is the delta sigma. Okay, so the delta sigma is sorry, no, the sigma naught. Okay, the sigma naught is the effective vertical stress, so the value is 134.4. Okay, so the maximum effective vertical stress that could be experienced by the clay layer can be computed as PC equal to 134.4 plus 74.78. Okay, so that is the PC value for the first estimation. Okay, which is 209.18. Okay. However, we are unable to directly decide which equation to be used in terms of the consolidation settlement due to insufficient information. Okay. So awak jangan confuse. This delta sigma yang dikira awal adalah untuk dapatkan PC. So we need to count what will be the we need to consider the new delta sigma. Okay. Uh, untuk kita dapat ataupun we estimate what is the pressure from the building. Okay. Okay, so the first delta sigma is to get the PC. Okay, roughly to get the PC. Okay, while the the delta sigma from the building. Okay, so we need to count. Okay, okay, by allowing only 50 millimeter of consolidation. Okay, okay. Walau bagaimanapun kita ada dua equation, so we need to choose or use the first one. Okay, if the first one is does not fit, so then we move to the second equation. Okay, so at this stage, the stress increase delta sigma due to the proposed structure is unknown. Okay, and need to be determined. Those we have to apply try and error method based on the given condition. Okay, so delta H is equal to 50. Okay, kita tahu. Okay, while H naught over 1 plus E naught CR already we know. Sigma naught kita boleh tahu. Sigma naught satu lagi pun sigma bawah ni naught kita tahu. Uh, the things that we doesn't know is the delta sigma. Okay. Okay. So based on the equation, the stress increase at the midplane of the clay layer need to be determined. Okay. The value of initial void ratio to be used in the equation above can be found using the relationship. Okay. Okay, using the relationship. Okay, yang ini standard lah. Okay, where E is equal to 0.91. Okay. Then rearrange the equation. Okay, whereby delta sigma should be put on the left and the rest should be on the right. Okay. So yang ini awak nak pindah ni log, dia akan jadi anti-log kan. Okay. So at the end, the delta sigma value is equal to 55.1. Okay. So macam mana kita nak tahu benda ni betul atau tidak? Okay. So then we need to do, we need to compare, okay, the delta sigma value, the new delta sigma value plus with the effective vertical stress and compare with the PC. If the PC is greater than the delta sigma, the new delta sigma and the sigma naught, so means that the first the assumption that we made, the the first trial that we made is correct. Okay. So after obtaining the stress increase, it is necessary to examine whether the assumption PC was correct. Okay. Those, okay, kita dapati bahawa 134.4 plus 55.1, okay, it is less than the PC value. Okay, so satisfies the assumption. Okay, if the previous assumption is not satisfied, another consolidation settlement equation for over consolidated claim must be applied. Okay, so kalau lah contoh value yang ini lebih besar dari PC, so we need to use the second equation. Okay, okay. Then is required to estimate the maximum allowable pressure. Okay, yang ini delta sigma 55 ni adalah pada kedalaman mid plane of the clay layer. Okay, so berapa nilai pressure yang datang daripada structure itself. Okay, so then use the applying 2 to 1 methods. Okay, where the delta sigma, okay, which is 55.1. Okay, so then you rearrange the equation where you want to get the Q. Okay, so then the value of the Q is 78.5. Okay, so ada soalan? Ada soalan? Kalau awak faham yang ni, memang awak faham semua lah. Senang lah. Okay, faham eh? Okay. So awak dah faham the concept of normally consolidated, over consolidated. Okay. So how we apply this concept in the settlement calculation. Okay. So then if we have what we call as a allowable settlement value. Okay. So what will be the pressure from the structure which is required the proposed allowable settlement. Okay. So actually you already understand the whole concept of consolidations or the settlement calculations. Okay. Okay. So now we move to uh, the equation, the question number 7. Okay. Data from a double drainage one-dimensional consolidation test conducted on saturated city clay are as tabulated in the following table. Okay. The diameter and thickness of the sample were 50 millimeter and 20 millimeter respectively. Assume the initial void ratio was 1.2. Okay. So the first question, determine the coefficient consolidation CV in meter square per year using log time methods. Okay. The final void ratio if the settlement due to the applied pressure was 1.5 millimeter. Okay. So this is the value or the what we call as the result from the lab. Okay. So then by using the log scale graph, we plot the result. Okay. So then this is the pattern. Okay. So the procedure has been given here. Okay. In order to determine what is the CV value. Okay. So the first step is to draw the tangent line. Okay. On the second and the third curve, consolidation curve. Then from there we get the 100 degree of consolidation. Okay. Then we choose any points or any points on the curve. Okay, for example, if we choose A, okay, draw a horizontal line. Okay, then multiply the value of A with 4. Okay, let's say it is equal to C. Okay, then draw a horizontal line. Okay, the distance between B and D, let's say it is a delta. So we need to extend the delta on the top of the AB line, where it is represent the degree of 0. Okay, so from 0 to 100, okay, we may divide into 2, okay, to get the 50%, okay, of the which is represent the T50. Okay. So the T50 is equal to mana ni? 10, 9, 8, 7. Bukan 7 right? 7, okay? Okay, 7. So the value of the CV is equal to 2.81 millimeter square per min, or 1.5 meter square per year. Okay. So then the B question, okay, the B question, the final board ratio if the settlement due to the applied pressure was 1.5. Okay. So I guess we use the first example based on the strain approach, a strain concept. Okay. So delta H over H naught equal to delta E over 1 plus E naught. Okay. So do the rearrange the value. Okay. To determine the delta E. Okay. Then from there we can estimate the or get the value of the final void ratio. Okay. So it's equivalent to 1.04. Okay. So that is for the example number 7. Okay. So let me share the example number 8 and 9. Okay. Let me stop first. Okay. Any question? Ada soalan? Tak ada. Oh, baguslah awak ni. Okay. Okay. Let me find. Okay. 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 So we look on the example. Saya pun first time tengok example ni. Jadi mungkin ambil masa sikit untuk memahamkannya. Okay. So, melainkan kalau awak dah faham ataupun benda yang sama. Okay. So, refer to, nampak kan? Okay. Okay, nampak Okay. Okay, refer to figure 2.8. How much extra surcharge Q has to be applied for a given time 5 months in order to produce 70% of the final settlement under the embankment load alone. Okay. The unit weight of the embankment is 18 kilonewton per meter cube. The thickness of the clay layer is 10 meter, underlain by medium dense sandy gravel. Okay. The groundwater table is located at the ground surface. Assume the area of the embankment is large so that the stress increase in the consolidating clay layer equal to the applied pressure by the embankment. Okay. So we look on the solution. To calculate the final settlement due to the embankment P, okay, we have P embankment, first permanent embankment, okay. So there is an additional surcharge. Okay. So then they will remove the surcharge because they uh, they want to gain what we call as a reduced level. Okay. So they want to get a new level. Okay. Because if they include the level of the extra surcharge, so that is not the required level that they want, or we call it the contractor one. Okay. To calculate the final settlement due to the embankment P using equation 2.1, there are items in the equation that need to be determined. Okay. For example, E naught, effective vertical stress as the value as not given. Okay. So I guess we can easily get this value, okay, because we already they have provided the W and GS, okay. Okay. So then the E naught is equal to 1.06, okay. And then for the mid plane of the clay layer, okay, which is 19 minus 10 times 10 over 2, because the thickness of the clay is 10 meter. So the value is 45. Okay. So that is the additional input that we need to include in the equations. Okay. Assuming the stress increase at the mid plane due to the embankment P equal to the applied pressure by the embankment. Okay. So unit weight of the embankment soil times height of the embankment. So 18 times 3, okay. So they assume it is a large and equal, okay, from the top to the mid plane, okay. So 18 times 3 is equal to 54, okay. So hence the final settlement due to embankment P alone is equal to 0.748, okay. So that is from the embankment P, permanent embankment P, okay. Okay. So the final settlement due to the embankment P and the assumed extra surcharge Q using similar equation 2.1. Okay. Note that delta sigma equal to P plus Q. Okay. So the Q is equal to, how they determine the Q, 45, 54, 54. The Q is 50. Okay, 71, 50. Mana dapat 50? Mana dapat 50? Sekejap. Saya tak nampak 50 kat mana. 54, 45. Apa saya tak mana dapat 50 ni? 18. Oh, let's try. Dia kata try. Okay, okay, okay. Dia try. Okay. So, let's try Q is equal to 50 sebab saya tak perasan dia ni. Okay, okay. Okay, then, okay, dia just try. 45, 54 and 50 over 45. Okay, this is due to the additional punya extra surcharge. Okay. While the rest doesn't have any change. Okay. So dapatlah 1.136. Okay. So the settlement at the time T due to P and Q is given as equation 2.7. Okay. So X is equal to delta H P plus Q. Okay. T. Okay. That is after the apply of the Q over delta PF. Okay. Which is after right after the apply of the permanent embankment. Okay. So delta H 0.748. Okay, X. So X, I guess X is 70% ni. Ni nampak ni. That is the X. Okay. So X is 70%. X 70%. So the settlement, okay, I guess they want to get what will be the final settlement. Does it similar or not based on the assumption of 50Q tersebut. Okay. So 0.524, okay, uh, which is the increment of the consolidation due to the degree of consolidation due to the additional of Q. Okay. So determine the degree of consolidation. Okay. Okay. So delta H. Okay. Delta H P plus Q over T. Okay. That is the final. Okay. This is the final. Actually, this is the final. Okay. Over. Sorry. This is the final. Okay. This is at the 70%. Okay. Is equal to 0.46. Okay. Okay, find TV from, okay, then the TV is equal to 0.175. Okay, so determine the time required, okay, using equation 2.6. Okay, so TV times HD power by 2 over CV. Okay, since the top surface of consolidation clay is exposed to the atmosphere, okay, free drainage, and the bottom of the case, so they consider as a double drainage. Okay, kalau sebelum ni kita dapati bahawa ada sand, clay, lepas tu ada whatever gravel. So yang ini pun sama jugalah. Seolah-olah dia terdedah kepada atmosphere. So water can move to the up and then go to the down. Okay. So double drainage. Okay. So HD is equal to 5. Okay. So then the time calculation is equal to 3.63 month, which is less than the given time of 5 month. Okay. So even though the time taken to achieve 70-degree consolidation is shorter than the given time 5 month, such additional surcharge may be little, large, and not economical, and may cause bearing capacity failure to the clay layer. Hence, it is suggested to reduce the extra surcharge, say 25 kilonewton, okay, and repeat the calculation. The price item due to embankment P is similar to the calculated previously. Okay. Oh, diulang balik. Okay, dengan reduce the number of the Q value. Okay, sebelum ni dia gunakan, they use the 50, they use the 50 kPa. Now they reduce to what we call 25. Okay. Okay. So actually we only not consider the settlement of the embankment. We also consider the if the the bearing failure. Okay. Okay. Okay, 25. Okay. So dia letakkan 25 here. Okay, yang ni samalah, ni sama. So dia reduce to 25. Okay, then they repeat the process. Okay. So okay, sama, proses sama. Okay. So from there, okay. So 150 days, okay. So they achieve 150 day is equal to 5 month, okay. So at the end, they want to get the same, as mentioned here, okay. Mana ni? The 5-month value, okay. When they use the Q of 50, okay. So the process of consolidation is completed within 109 days, okay, under 70%, okay. So then they need to reduce, okay, the what we call as the the weight or the pressure from the additional load. Okay, so when they reduce to 25, okay, so then they obtain 150 days. Okay, okay. So here's an additional charge of 25. Okay, approximately 1.5 meter height of additional charge would be appropriate. Okay. Dia kalau terlampau besar, dia menyebabkan okay, actually during the constructions of the embankment, okay, we need to monitor, okay, the development of the pore water pressure. Okay, so in terms of instrumentation, okay, if the development of pore water pressure is very fast, so the possibility of the what we call of the environment to fail is high. Okay, dia ada calculation dia. Dia tak boleh lebih 0.7. Okay, cannot exceed 0.7. Okay, from the original pore water pressure. Okay, so if greater than definitely the environment will be collapse. Okay, so that's why yeah, this calculation is very good. Okay, especially when you want to design for the embankment or the additional surcharge on the embankment. Awak mungkin guna nanti waktu awak kerja. Okay? So yang ini saya rasa dah apa dah boleh untuk practice ni. Okay? Ada soalan? Tak perkara ni nanti awak go through balik apa yang saya explain. Okay? So soalan dia how much within 5 months to produce 70%. Kan kita kira 70% tu mana kita bandingkan antara permanent embankment punya settlement dengan additional punya extra surcharge Q punya apa embankment settlement. Okay? So when we compare does uh, ah we assume it is 70%, okay, but we need to make sure that it is should within the 5 months punya durations, not less than 5 months. Okay, sebab dia kata kalau even though the time taken is 70% is shorter than the given time, such additional system may be too a little too large and not economical or may cause bearing capacity failure. Okay. So kemungkinan in term of masa kita dapat jimatkan masa. However, we need to look on the actually Dr. Kamil doesn't discuss on the pore water pressure development. Okay, we also need to look on the development of pore water pressure. Okay, so yeah, the development of pore water pressure only could be determined if we do the monitoring. Okay, okay, okay. So the last question, woi panjang. Okay, saya laju, saya tengok mana yang boleh skip, saya laju eh. Okay, refer to the diagram Q29. It is anticipated that a permanent embankment will exert a uniform pressure of 120 kPa on the soft clay layer. The ground table is situated at 3 meter below the ground surface. Okay, so this is the groundwater, 3 meter. The total settlement of the clay layer due to the permanent embankment. Okay, okay. So the total settlement of the clay layer due to permanent embankment. Okay, H naught is 12. Okay, okay, 12. 1 plus 0.8. Okay, 0.8 is the E naught. CC is 0.42. Okay, log. Okay, yang ini delta sigma naught is 138 based on effective vertical stress. 18 times 3, 19 minus 10 times 2, 21 minus 10 multiply with 12 over 2. Okay, so dapat 138. Okay, so then the 120 is the apply uniform pressure from the embankment. Okay, so 0.762. Okay, so that is for A. Okay, so B, the extra pressure surcharge required to be placed on the top of the permanent embankment to eliminate 50% of settlement due to the embankment alone within 6 months. Okay, so ada extra surcharge sama macam soalan nombor 8 tu. Okay, to eliminate 50% of the settlement due to the embankment alone within 6 months. So dia dah beritahu 6 months dan 50% from the settlement. Okay. So determine the final settlement due to the embankment P and assume extra surcharge Q using the similar equation. Okay. P plus Q. Okay. So sama juga dengan sebelum ni. Let's try. Okay. 100. 101.16. Okay. So 0.5. So dia kata nak achieve 0.5. Sorry. Achieve 0.5 within 6 months. Okay. So saya rasa benda yang sama seperti mana yang kita discuss sebelum ni. Okay. Q100 0.5 3.38. Okay. So then TVC, then we look on the T calculate 8.5. So more than 6 months, not okay. So either we need to increase. We need to increase. Kalau dia singkat, we need to reduce. Okay. Contoh kita apply 200. So dapati dia less than 6 months. So we need to reduce. Okay. Try higher value of extra surcharge. Okay, 130. Ini dapat berapa ni? 0.38. Okay. Then 6.6 month. Not okay. Okay. So increase lagi. Oh, bendanya repeat je lah ni. Okay. 5.6 month. Less than. Okay. Then from there, we need to, it is enough to have 3 times of attempts. Okay. So sebenarnya yang nombor 8 tu pun we do only 2 attempts and then the second attempt we already get the 5 month. So we get the result, the same result. But for this question number 9, okay, we keep doing the try and error, the several attempts, but we still not achieve the 6 month. Okay, so what should we do? Then we need to stop until 3 attempts minimum. But for this case, Dr. Kamaluddin go for 4 attempts. Okay. So by doing this, okay, so we plot the times over additional surcharge. So from 6 months, so we can estimate the additional surcharge should be around 140. Okay. So reader may work backward without try and error based on equation 2.6. The TV determine the TV where HD, CV, and T is equal to 6 months. Okay. So then CV is okay 0.06. Okay. From figure 2.2, okay, UV is 30% using equation 2.7. Okay, rearrange the equation to obtain the final settlement due to the permanent embankment P and additional surcharge Q, okay, is equal to 1.27. Okay, using the consolidation equation for normally concentrated clay, okay, rearrange to obtain Q, okay, where M, okay, dia rearrange balik, so dapat Q di sini, okay, M is equal to 0.4536. Okay, those Q is equal to 134. Okay, so the value obtained close to the what trial and error. Okay, so lebih kurang sama lah. Okay, so 140 is slightly similar to 140. Tapi cukup memadai awak buat sampai sini lah. Awak plot the graph. So from the graph, you determine the 6 month. Based on this relationship, then you obtain 140. Okay. So then for the C, okay, the C, what is the C? Then the minimal spacing, okay, if, oh, with drain, preluding to achieve 50%. Those with the thickness of the strip, okay, yang ni awak tak belajar ni, ini adalah vertical drain. Okay. Yang ni vertical drain ataupun PVD, prefabricated vertical drain. Saya rasa yang ni awak tak belajar. Okay. So yang ni perlu diabaikan. Okay. For the C. Okay. Sebab saya pun tak terang kot untuk C ni. Okay. So I guess that's all for the consolidation. Okay. And settlement topic. Okay. Awak ada beberapa minggu lagi ya? Saya stop dulu recording.